Good afternoon, everyone. We hope everyone is well and able to catch up some rest and enjoy longer days. We are truly thrilled to welcome you to our webinar today, diving into Vibriosis, presented by Laurie Stewart, who is a cherished foodborne and waterborne disease epidemiologist and the subject matter expert for Vibriosis at Washington State. My name is Sonia Littman, and I am grateful to serve as a program manager for Washington State Integrated Food Safety Center of Excellence and as a foodborne enteric epidemiologist at the Washington State Department of Health. Before we get started, we wanted to let you know that this webinar is being recorded, and both the recording and the slides will be made available on our Washington COE website. Let's see, next slide, please. Okay. In the interest of time and to allow for ample Q&A, we are going to skip the COE slides, as many, if not all of you, are already well aware of COE. And so with that, we are so excited for Laurie to present today on Vibriosis, as we have heard many requests for this very topic from multiple state partners. With over 27 years in public health, Laurie Stewart currently works as a foodborne disease epidemiologist at the Washington State Department of Health. She earned a Master of Science degree in public health from the University of Hawaii and is currently a clinical instructor in the Department of Epidemiology at the University of Washington School of Public Health. Laurie is also an empty nester with a 20-year-old son, an urban hiker. I believe she went on a 6-mile hike just last weekend, a lover of food, cooking, books, and podcasts. So thank you so much, Laurie. The floor is yours.
Hi, good afternoon, everybody. Hey, that was actually a 9-mile hike, Soyan. So I just want to get credit for that. Thanks
9
for that
miles.
introduction. Okay. So I am really glad to be here. My name is Laurie Stewart, and I am privileged to be included in this webinar sponsored by the Washington Integrated Food Safety Center of Excellence. So today I'm going to talk about the organisms that cause Vibriosis illness syndromes, typical components of a Vibriosis illness investigation, and identifying Vibriosis clusters and outbreaks. And before I go into that, I just wanted to mention that in the webinar, we would like you to use the Q&A button if you want to pose any questions during the webinar. And that's a better way to do it than to put them in the chat. So if you've already put a question in the chat, you could throw it over into the Q&A section. Thanks, that would be great. This training is primarily for public health staff, including epi and environmental health staff who investigate Vibriosis cases or conduct environmental health assessments, or just anyone who really wants to know any more about Vibriosis investigations. So by the end of this training, you should be able to identify the 3 Vibrio species that are most likely to cause human illness in the United States, describe 3 interview questions that can be used to elicit a detailed shellfish history, and explain how shellfish traceback information is used to identify Vibriosis outbreaks. So there are 14 Vibrio species and 2 non-Vibrio organisms that cause Vibriosis. All of these organisms prefer warm, salt, or brackish water. And if you're unfamiliar with that term brackish, it just simply means a mixture of salt and fresh water. And this is often found in estuaries where fresh water from rivers and streams mix with salt water from the ocean. So what I'm not going to talk about today is toxigenic Vibrio cholera 01 or 0139, which cause the disease cholera. That's a different disease entity with different symptoms. And so I'm just talking about Vibriosis today. So here's a list of the organisms that cause Vibriosis. And this is an alphabetized list. And you can see that at the top here, Gramantia halaceae, that's a non-Vibrio organism that's in this group, and Photobacterium damselae, subspecies damselae. And otherwise, everything on this list is a Vibrio organism. So the number one organism that causes illness in the US is Vibrio parahemolyticus. The second is Vibrio alginolyticus. And the third is Vibrio vulnificus. So here's that same listing, but it has them ranked by occurrence. So Vibrio parahemolyticus, alginolyticus, vulnificus round up the top 3, and they're followed by non-toxigenic Vibrio cholera, Vibrio fluvialis, Vibrio mimicus, Gramantia halaceae, and Photobacterium damselae, subspecies damselae. I'm not sure who came up with that name. The next 3 are approximately tied: Vibrio farnesii, Metznikovii, and Harveyi. And then the rare species are at the bottom: Campbellii, Cincinnatiensis, Mediocus, and Nevarensis. And the only reason I'm able to pronounce those is because I've had practice. So the top 3 species are what I'm going to focus on, and I'm using data from the 2014 CDC annual report. This is the last year they've published data for the entire country by species. And I looked, so this is just one snapshot. This is 2014. But if I look at all of the annual reports that they published, these numbers hang together. So parahemolyticus is always at the first top, alginolyticus is always the second, and vulnificus is always the third. I just wanted to give you an idea of the case, what the proportion of cases look like. These still hold, as far as I know. They haven't really published any data, but over those years that they did publish up to 2014, they held together with these approximate proportions all those years. And also, I just want to mention, these are single species only. So somebody may have been infected with parahemolyticus and mimicus, for example. That doesn't show up here. So these are hospitalizations by Vibrio species, also from 2014. I did look across all of the years, and these proportions hang together. Vibrio vulnificus, you can see there, has a 79% hospitalization rate. And so that's obviously the highest. And parahemolyticus and alginolyticus are much lower. They usually cause much less severe illness. So that just gives you a hint at how much more severe vulnificus can be. So the mortality rate by Vibrio species has Vibrio vulnificus at 18%. And over all of the years, it was around 22%. I've seen published data that say it's like from 20 to 50% even. But really, when I looked across all of the CDC published data, it was around 22%. So as you can see, it's quite rare to die from parahemolyticus, and really, really rare to die from alginolyticus. And you'll see in a few slides why that is, probably. So I'm going to talk about Vibrio illnesses. So Vibriosis is featured by 3 different illness syndromes: gastroenteritis, skin, wound, or ear infections, and septicemia. So gastroenteritis caused by Vibrio infection the foodborne source. It's by consuming raw or undercooked seafood. That's the primary way people get sick. You can also get sick by eating foods cross-contaminated with raw or undercooked seafood, or by eating cooked shellfish that's been stored in seawater. You might wonder, when does that happen? Well, when people are out on their boats, they might, I've heard of people cooking up crabs on the boat, and then they don't know what to do with them, so they pull up a bucket of seawater and they immerse the crabs in there, and that's how they cool them off, and then that's how they store them. Well, as you can imagine, that warm seawater is a great growing media for Vibrio proliferation. And I've investigated a couple of cases and at least one outbreak that was associated with this type of exposure. But again, the most likely exposure is just the direct consumption of raw or undercooked seafood. Incubation period is usually within 24 hours, but it can range from 4 to 96 hours. It causes watery diarrhea. People often complain of cramping, nausea, vomiting, fever, and this can actually progress to septicemia in some cases. The duration is days to weeks. The people who get tested are typically people who have had diarrhea for 3 days or longer. If it's shorter than that, people just I'd probably assume it's norovirus or something else. It's not transmitted person to person. And the most likely cause in the United States is Vibrio perihemolyticus. Non-toxigenic Vibrio cholera and fluvialis also kind of round out the list. Vibriosis, skin, wound, or ear infections are caused by skin exposure, and that can happen during swimming, working, fishing, etc., in salty or brackish water, especially if you have pre-existing wounds. There's sort of a common belief that going into the salt water when you have a pre-existing wound is somehow therapeutic. It is not. It's actually a really good way of getting a Vibrio infection, or there are a lot of other organisms in the water, and it's a good way of getting any type of infection. So don't do that. The other thing I wanted to mention is that some people actually sustain an injury while they're recreating in the water or working. So they may stub their toe on a sharp rock or a piece of coral, and that's often the story we get when we investigate those cases. The incubation period is usually within 7 days of exposure, and the symptoms are pain, redness, or swelling. This can progress, especially with Vibrio vulnificus, to necrotizing fasciitis and or septicemia. The duration is days or weeks. With Vibrio vulnificus, it could actually be months before they recover, if they do recover, and it is not transmitted person to person. And most likely causes are Vibrio alginolyticus for sort of non-complicated skin or outer ear infections. But Vibrio vulnificus is the most likely cause of those severe skin infections, and especially the ones that progress to necrotizing fasciitis. So septicemia, you can get that either through the foodborne route, or you can get it from direct skin exposure to salty or brackish water. The incubation period is, we think it's 12 to 72 hours. It's kind of hard to say because sometimes people start with those wound infections or the gastroenteritis, and then it goes into the septicemia. The symptoms are fever, chills, dangerously low blood pressure, blistering skin lesions called bulla, and the duration is days to weeks or even longer if they require rehab. There's no transmission person to person, and the most likely cause is Vibrio vulnificus. There are other organisms can cause septicemia, but the most likely cause is Vibrio vulnificus. So this is just a slide showing you the seasonality of these infections. So you see the blue line are the foodborne cases, and that has a peak in late July, August. The skin infections are in the orange line. They have a less seasonality, and that's just because people during the winter months often will go to warmer climates. They may go to Florida, they may go to Mexico, Southern California, and Thailand. I've seen cases from Thailand. And so they're getting those maybe on the off season. So that's why there's less of a seasonality with those skin infections. So how is Vibriosis diagnosed? So culture is the gold standard, that you can do Vibrio culture on stool, wound, ear swabs, or blood. And I just wanted to note that stool culture for Vibrio requires special media. It doesn't grow on the same media that you would use for Salmonella or Shiga toxin producing E. coli or Shigellosis. And so it's not always inoculated. And so it really helps if the physician tells the lab that they suspect Vibriosis, because otherwise the lab may not inoculate the correct media. So I imagine that multiple cases of Vibriosis are missed for this particular reason. Culture independent diagnostic testing is also available, and Vibrio is included in some enteric pathogen panels. It's only available for stool specimens. And so if you see a a culture with a CIDT PCR result. That means that was a stool specimen. One disadvantage is that there's no isolate that results from that testing. And so if you want to find out definitively what is the species, you don't have an isolate that you can do further testing on. Also, if you wanted to do whole genome sequencing, you don't have an isolate you can do whole genome sequencing on either. The advantage of the CIDT testing is that it's rapid, and it's a lot of labs are switching to it. It's just not, you just don't end up with an isolate. In an ideal situation, the clinical lab would do a reflex culture. That means that if they got a positive on a PCR test, that they would reflexively run a culture. Not all labs even have that capability anymore. And so in Washington State, what we do is we have them submit the specimen to the state public health lab, and we work it up there. We acknowledge that that's maybe not possible at all state public health labs, but that does work out pretty well for us in that situation. I did want to make one comment about the PCR testing, because there's a couple of PCR panels that include Vibrio species and Vibrio cholera. And some people are incorrectly believe that the Vibrio cholera test is testing for toxigenic Vibrio cholera. That Vibrio cholera Vibrio cholera 01 or 0139 that causes the disease cholera. And that is not what it's testing for. It's just testing for Vibrio cholera species. So don't get alarmed if you see a positive Vibrio cholera on your PCR test. That just means they've detected Vibrio cholera species. So Vibrio is really an opportunistic infection, which means it's not an equal opportunity infector. So if you have underlying conditions that make you more susceptible for infection, you may be the person who gets infected out of a group of people who are exposed. So for example, you may investigate a case where 5 people all shared raw oysters together, and only one person gets sick. Well, why did that one person get sick? Well, often it's the person who has some kind of underlying condition. It's diabetes, it's reduced stomach acid because they were taking antacids, or they've had gastric surgery, something like that. Vibrio is less likely to cause, it usually often has a lower attack rate because not everybody is equally susceptible. Unlike a Vibrio infection, a norovirus infection, for norovirus outbreaks that are associated with shellfish, usually everybody gets sick, or almost everybody gets sick when they are exposed. So that's one sort of indicator that this illness is a Vibrio infection rather than a norovirus infection, for example. So some of these complications, these risk factors can also put people at higher risk for complications. And by complications, so people with liver disease, hematologic disease that increases like iron stores, those people are much, much higher risk for serious complications from Vibrio vulnificus, for example. These are the people that they're talking about when you see those consumer advisories that say some people should not be eating raw shellfish. So Vibriosis case investigations are next. And I'm just going to start with this slide because I'm going to be focusing on molluscan bivalves, in particular oysters. And the reason I'm focusing on molluscan bivalves is just the way they nourish themselves, the way they grow. So the way they nourish themselves is they siphon in the water that they're grown in into their body, and it sort of pulls out all the nutrients that are in the water, and so that they can grow. But it also pulls in any kind of bacteria or any viruses or potentially other things like toxins. It will pull them into the meat of the shellfish, and that will get concentrated. So I'm just going to do a little animation. So just pretend these red dots are Vibrio. They're getting sucked into the bivalve and they're getting concentrated. So you end up with a higher concentration actually in the shellfish than is in the water. I'm not focusing. I'm going to focus on oysters, but I'm not trying to pick on them. The reason I'm just going to mention oysters a lot throughout this presentation is because people so often throughout the country eat those raw. So the other thing I'm going to start with talking about is a shellfish tag. So this is just an example of what a shellfish tag looks like for bivalve shellfish. They are required by the FDA, the National Interstate. Sorry, I just went out of my head. So anyway, they're required by the FDA to carry these tags. And this is so we can do traceback. This is sort of from the hepatitis A days, like way back when. That's why they have to keep them on file for at least 90 days. And the reason is that is based upon the incubation period for hepatitis A. But it's really great. So if a restaurant sells shellfish, they have to keep these tags on site for at least 90 days. So if an illness occurs that looks like it's associated with the shellfish, environmental health can go back in and look at those, say, give me all your tags that for shellfish that were sold this day, and they can do a trace back. And that way we can trace the shellfish that are associated with the illness. Sorry about that. So here are just some basic investigation steps. These are not true for every single investigation, but they are true for a lot. So you do a case interview, field investigation, you do seafood traceback, and then you identify clusters and outbreaks, and then you report. So if there's no seafood, you're not going to do a seafood traceback, and if it's not foodborne, you're not going to do a field investigation typically. So just keep that in mind. So here is on this little thumbnail is a COVID and other Vibrio illness surveillance form. This is a CDC form, and this has all the variables on it that the CDC wants to know about. You want to interview your case with a standardized questionnaire. You can either use this, or if your state has another standardized questionnaire that includes all these questions, that's great too. I'm just going to click on my internet. So here is the CDC website for cholera and other Vibrio illness surveillance. And it really has great information on here. I highly recommend you look at this page. And I'm just going to click on the COVIS form and show you what that looks like. So this first page is just for you to keep track of the case with. You don't send that to CDC. So here is how it starts. And it's got all the information, demographic information at the top. One thing I wanted to mention here is that it does have some personal identifiers. And I would strongly encourage you that when you send this to CDC, CDC is probably not going to like me to say this because it's going to be harder to trace these cases. Or if you send them to another state, that you do take off the last 3 letters of the patient's last name and the date of birth. And in some cases, the occupation. I've seen some forms that actually have like it'll say mayor or police chief or something, and then it'll have the city listed. And I'm like, okay, I can figure out who that person is. So the unique identifiers, though, are these NNDSS case ID and the state case ID. This is the CDC ID. This is the state case ID. Definitely leave those on. Sorry, you do need to send the last 3 letters of the last name to CDC. Sorry, I just want to correct that. But you don't need to send the date of birth or the or occupation if it's identifiable. Sorry. So then I'm just going to go through. You have here's all those Vibrio species that I just mentioned, and then here's where you indicate what kind of test was done. And this is really important to fill out, because if you don't fill this out and you send this form to CDC, they are going to come back and ask you to send it to them. Actually, CDC does really good confirmation of all these variables. And if you don't fill all these variables out, they will come back and ask you for them. Just warning you. Whether they were hospitalized, all these symptoms, underlying conditions, and here's the shellfish exposure. They want to know yes or no to every single one of these. And here's the section on water exposure. If they our foodborne case, CDC does still want to know about water exposure, so please fill it out if you're able to. If they are a non-foodborne case, then definitely fill out this water exposure section. And then here's the seafood investigation page. And I'm going to talk about this later, but at the top of the seafood investigation page is where you sort of indicate which is the seafood we're going to investigate. And then this is a section that's completed usually by environmental health. So I'm going to close that and go on. So it's really important to get a really good shellfish history when you're doing a Vibrio investigation, if it's a foodborne case. So people often don't remember what kind of shellfish they had, and these restaurants often will have a bunch. They will have sometimes up to 25 different oysters that they're selling. And so as descriptive of information as you can get from that case patient, the better, because then when they go to the restaurant, they will be able to collect the appropriate information. So I always like to look up the restaurant menu online. I like to look, pull it up and find out when they ate, what time they ate, and which meal they ate, and then pull up that particular menu, because they will often have a separate dinner, lunch, brunch, happy hour menu, and you can pull up just that menu. Sometimes there's even a special oyster menu. We will find that often with seafood restaurants. They will actually have a special page that they hand out separately. If you can pull that up, that would be great. Ask what is the exact name and description of the item. How many varieties did they eat? If they can remember they only had one variety and it was from one particular geographic area, then that may help environmental health pinpoint exactly which variety was eaten by the case. How much did they eat? That will kind of tell you what was the dose that required an infection. Did they eat just one, or did they actually eat 20 or 30, which does definitely happen. Also ask them if they have receipts. If it's a restaurant that charges by the oyster or by the item, then it will probably list them separately on the receipt. People now like to take photos of what they eat and post them on Instagram. So if they don't have really good information, ask them if they posted a photo. That may help environmental health figure out what they ate too. So if they shopped at a seafood center grocery store, there's slightly different information you'd want. You still want to know the date and time of purchase and the date and time of consumption, but you also really want to know, how did they handle the product between purchase and consumption? Was it in their trunk for 8 hours in the middle of August without any ice? Or was it 5 minutes from their house and they just went from one to the other, or did they keep it on ice? The other thing is sometimes, often that they're sold on ice, and if they don't add additional ice, as that ice melts, then that's an issue. So you want to find out if there is any post-harvest abuse by the purchaser of the shellfish. Ask them if they have a receipt. It might have the exact item listed. If they don't have the receipt, you could ask them if they have a shopper or loyalty or membership card, because maybe you can contact the store and if you with the permission of the case patient, and you can find out what they ordered based upon that shopper card. How was the shellfish purchased? Was it in the shell and the case patient took it home and shucked it themselves, or did they pre-shuck it? Do they have the packaging for that pre-shuck product? The pre-shuck product is often sold in a canister or a jar, and there's no tag for that, but the information should be on the lid or on the label. If they got it in the shell, it should have the tag. And so I've actually asked people, could you dig through the garbage and find that little bag that have the oysters in it? Or could you go and look for the lid or the canister that had the pre-shucked product? So there's always a question of what seafood should I investigate? So if somebody might go to a seafood restaurant and they ordered the seafood tower, and it includes steamed clams, deep fried fish and chips, deep fried shrimp, raw oysters, and some investigators might think, well, these are all seafood, so we should investigate all of them. Well, no, actually, what we want you to put on the top of this form, we want you to prioritize the seafood that's investigated, and you're going to put it on this page, top of this page 5 form, and you're going to use this list that I got from the CDC. They have already basically made this decision for you. So if the patient ate raw bivalve molluscum sea shellfish, that's the one you want to investigate. So that's what you're going to put at the top of this form. You're not going to have environmental health investigate the fish and chips and the raw oysters. You're going to just have them go and look at the raw oysters. So let's say they didn't have any raw bivalves. Well, let's look at the cooked bivalves. Sometimes restaurants will undercook those. Maybe they put them under the broiler and they just cook them until the shell opens. Well, that may or may not be high enough temperature to kill Vibrio. What if they didn't have any cooked bivalves? Well, then you go to the other raw seafood, such as tuna, salmon, shrimp, crab, or octopus. If they didn't have any of those, then you go to the cooked fish. And then if they don't have any cooked fish, then you're going to look at the cooked crustaceans. So they've laid this out for you. What I don't want, what is not supposed to happen is that you send in a COVIS form to CDC and it has traceback information for every single seafood that they ate, regardless of risk. So the environmental assessment, I want to click on this resource because this is a resource that's part of our Vibrio toolkit. I didn't mention that at the beginning, but we've put together a Vibriosis investigation toolkit. And this is one of the documents that's going to be part of that. So this is an environmental assessment guidance sheet for environmental health. When you ask environmental health to go out and do an investigation, they can use this to give them sort of an overview of what they should be looking at. And I'm just going to kind of go through it a little bit. It tells them who to notify, what do they do before they go to the food establishment, Interstate Shellfish Sanitation Conference. They're the ones, the National Shellfish Sanitation Conference is who says they have to have the tags. And they work with the Interstate Shellfish Sanitation Conference. So the field investigation, this is what they should do while they're there. And control measures, what should they do if they identify a problem? Should they collect specimens? Usually no. And how do they report? How do they report cases? How do they report outbreaks? I'm going to close that. That's going to become part of our Vibrio toolkit. The first thing that they need to do is identify the approved source, and that entails collecting the shellfish tags and invoices. The next thing they want to do is identify any risks associated with receiving, storage, preparation, cooking, and temperature control practices. They want to evaluate the consumer advisory. And what we mean by that is if you look at this sample menu for a restaurant called She Sells Seashells, the consumer advisory is right here in the middle. It says consuming raw or undercooked meats, poultry, shellfish, seafood, shellfish, or eggs may increase your risk of foodborne illness. If your state has a seafood advisory or a consumer advisory, they should check that. Not all, I don't know if all states have that. Implement control measures. If they found problems with cold holding, like the refrigerator wasn't working, then they need to make sure they fix that, make sure that's fixed before they go. And then communicate findings, complete the COVIS form. So here's what we mean by complete the COVIS form. So at the bottom of that page 5, that's the case in the investigation form. That's page 5 of the COVIS form. Is a section, the middle is a section about the vendor information. So this is environmental health can complete this by completing what was the date they received the shellfish or the seafood? Was it imported? Was an assessment conducted? This should always be yes. Just going to say that again. This should always be yes. They should not go and grab the tags without doing the assessment. And was there evidence of improper storage or handling or storage? The reason they need to do that assessment is that if we do indeed find that that shellfish is associated with, or that illness is associated with this particular growing area where the shellfish came from, if the assessment was not done, and if they did not consider whether there was improper handling or storage, we will never be able to attribute the illness to that growing area because it may have been related to handling or storage at the facility. So again, they should always do an assessment, environmental assessment. And then the next section they would do is this. This is were there tags available? And if so, please fill out this information. Sometimes what we would do is environmental health would fill out an environmental assessment form, and they would, which was basically what their field investigation form, and we would take the information on the form and put it onto the COVIS form. So that's another way to do it. In any event, you need the tags. All that information and the tags needs to go with the COVIS form, and the COVIS form needs to go to CDC, and it also needs to go to the agency that regulates that shellfish, which I'm going to talk about next. So if you identify shellfish grown in another state or another territory, such as a Canadian province, then you need to notify the shellfish regulatory agency in the jurisdiction where the shellfish was harvested. Again, I don't know if everybody knows this. If you identify shellfish grown at another state or territory, or your own state or territory, you need to notify the shellfish regulatory agency in the jurisdiction where the shellfish was harvested. Some people may think that when you send the COVIS form to CDC, that is happening, but that does not happen. CDC does not forward those on to the states where the shellfish come from. It's really a responsibility of the agency that's doing the investigation. So when you do that, you want to send information about the illness and exposure to the shellfish regulatory agency in the jurisdiction where the shellfish was harvested. You can either send the entire CDC COVIS form with the identifiers redacted. That means all the last three letters of the first three letters of the last name, the date of birth, and the occupation if it is identifiable. And then or you could take page 5. Here's another option I've seen work. You take page 5 that's completely completed. That's the shellfish investigation page or the seafood investigation page. And you add the testing status, whether it was culture positive or CIDT positive, and the onset date of the case. That's typically what they want to know. Certain regulatory agencies may want other information, so you can kind of see how that goes on a case-by-case basis. But from my experience, that's what they usually want to know. Include all tags collected, including tags for product harvested in other states. So for example, if there's a Vibriosis case and they had shellfish from both California and Washington, I will send them the tags and the information from both California and Washington and say, here's the onset date, and they were culture confirmed or whatever. If you don't have the tags, you could send the invoices and they could potentially do kind of backtrack and figure out what the tags should be. So now I'm going to talk about Vibriosis cluster and outbreak detection. So one positive thing about Vibriosis is that you do a traceback on every foodborne, ideally on every foodborne case. So unlike Salmonella, for example, where you don't do a traceback usually on every single case, you wait till you have a cluster of cases and then you do traceback. You find out if they have anything in common, then you do traceback. With Vibriosis cases, because they're almost all seafood related, you do trace back on every single case, ideally. On a negative note, however, it's really hard to attribute an illness to just one particular product because people tend to eat multiple products. Or if they don't eat multiple products, they don't remember what they ate. So both positive and negative. So the best case scenario for trying to attribute an illness to a particular source is what we call a single source exposure. What we mean by that is they had the same shellfish, so let's say oysters. It was from the exact same growing area, and it had the same harvest date. So that's a single source exposure. If it's a culture confirmed case from a single source exposure and there's no post-harvest abuse identified, then that illness is attributed to that growing area. Those are, I would say, 5 to 10% of cases, or even probably lower, actually. So the other cases, I'll give you a little example of what I mean next, but most cases are not those single source cases. So what about whole genome sequencing? So whole genome sequencing can be helpful in certain situations, but there are some hiccups to using whole genome sequencing. One is that shellfish are moved around before and during the season for various reasons. They may be moved from an area that's higher risk for Vibrio perihelmiticus. Maybe it's a great place for the shellfish to grow, and then during the harvest season, they move them to a lower risk area. Certain strains may predominate in one region. For example, in Washington state, it seems like one particular whole genome sequencing strain or strain identified by whole genome sequencing predominates throughout much of the Puget Sound and coastal region. So it's not specific enough to use whole genome sequencing data to identify particular exposures. And then the other thing is that oysters are often moved from multiple areas, and they may share the same wet storage. And the wet storage may be just an area where they're being held. Maybe they're being held to try to have them get rid of some of the Vibrio that's in their system. There's multiple reasons for wet storage, but they could be there from multiple areas, multiple different growing areas. So I just wanted to mention that. So illness logs, this is something that a regulatory agency, or we work with our Washington State Shellfish Program and look at these data. This is a real cut down version of what they actually use, but it has the fields that I think will illustrate how they use these tags. So when they get illness information and tags from either Washington State or any other state, they put them on an illness log. And for each case, the illness number represents a single case. Each case has a number, and each line has a tag. So as you can see, case number 1 had 4 tags, A, B, C, and D. And you can see each tag has slightly different information. The meal date was 8/11, their onset date was 8/12, and then they had oysters from these 4 areas. I left it off here, but these are all raw oysters. There was no post-harvest abuse. So when you look at, you can look at this, case number 2 had 2 oysters, case number 3 had 1 oyster, and case number 4 had 1 oyster. If you look at, these 2 had Luley Bay oysters in common, but they were both multi-source oysters. They both had 2 tags. Then you have this case that had, is a single source case, but if you look at it, it's not culture confirmed. And if you look at this 4th case, they also had Luley Bay oysters, but it is culture confirmed. So here's your little cluster. So that's how they would use these illness logs, and that's how they use the tag information. So whole genome sequencing for cluster detection is a little bit more dicey. And I'm just going to give you an example. In July 2018, CDC identified 116 Vibrio perihelmiticus isolates that were highly related via core genome multilocus sequence typing. 60 cases had documented raw oyster exposure. 32 had reliable traceback data. And there was a cluster identified, 9 consumed oysters from a particular Washington State growing area, which was then closed for shellfish harvesting. So 19 other cases, though, had oysters from a variety of growing areas that did not include this area, this Washington State area. They had other Washington State areas, but not this one. And then there were 4 that had oysters only harvested on the East Coast. So we don't know whether that could be from many reasons. One reason is it could be that they collected the wrong tags. The other reason, maybe shellfish are moved from the West Coast to the East Coast. So there's multiple reasons why that might happen, but I just wanted to show you why whole genome sequencing is not as nice and tidy as it is for salmonella or Shiga toxin producing E. coli traceback. So for reporting, COVIS form should be submitted for all cases. For outbreaks, you should submit the NORS form and the NEARS form. That's National Outbreak Reporting System and the National Environmental Assessment Reporting System. And for tools and resources, we're going to have this Vibrio toolkit shortly. The CDC website's awesome. It's got a ton of good information. The Washington State website I have up here, we have example investigation guidelines and forms and some other information that you're welcome to steal from us. Just try to give us some little credit, but we don't mind if you want to steal from us because we've probably borrowed from you as well. And then the Washington Integrated Food Safety Center of Excellence, please go there. There are other presentations there and we encourage you to look at that. Q&A. Are there any questions?
Thank you so much, Lori. Before we get to the questions, I'd like to mention 3 items, please. The slides on the recording will be posted on our Washington COE website. And if you registered for this webinar, you will receive an email when they are posted. And thank you so much, Vi, for sharing. We have many folks from California joining this webinar. So I want to highlight her comment, which is for participants from California. Please note that we do not use the CDC form that Lori is using, or Washington is using, but we have all of their questions on our own version of the case report form. And then third, Anne is entering the evaluation link in the chat box. And please do complete the evaluation, as your feedback is tremendously valuable and needed to improve our efforts and guide our collective COE work. And we truly, truly value and appreciate your feedback. All right.
Okay, so I'm just going to go and answer some of these questions. Is there any data on viable living conditions for these organisms in terms of temperature thresholds in water? What water temperatures propagate growth versus inhibit growth? So what I can tell you is the warmer, so waters in, I wanted to mention this during the presentation. Well, Vibrio perilyticus is found throughout the United States on east and west coasts. And actually, Alginolyticus is found on east and west coasts throughout the United States, or throughout the coasts, not throughout the United States, not on those landlocked places. Vibrio vulnificus is much more common in warmer regions. So while we have vulnificus on each coastline, we see more cases of illness associated with the Gulf states. So I can't really get into details. I do know that under 51 degrees, I believe, I don't know if it's somebody from environmental health maybe could write into the chat somewhere about this, but I know that it's not considered, I don't want to misspeak, I don't think it's considered temperature abuse if the temperature is, I don't even want to say this, but I know that I'm just not going to answer that because I can't answer it definitively, but there is data about this. Show the resource slide again. Yes, I would be happy to. There we go. And I'm going to just skip that question. See. Okay, so For the case definition, CIDT diagnosis cannot be considered confirmed without a culture. Is that correct? That is correct. The case definition for Vibrio requires culture confirmation. So if it's just CIDT positive or PCR positive, it is a probable. How specific should the body of water description be? So you want to try to get as specific to geographic area as possible. I would say you want to say if it was at a state park. I wouldn't say, you know, Puget Sound, for example, is way too general. I would usually, when people are recreating, it's usually at some kind of often it's at some kind of a park or beach. And so just use that name of the beach if possible. That's a good idea. Are oyster farms doing surveillance of their own in harvesting water? So that is a good question. I don't know. So there is environmental testing for Vibrio species. The problem with doing environmental testing for Vibrio species is that it's not all species of Vibrio parahemolyticus are pathogenic. Not even all species of Vibrio vulnificus are particularly pathogenic. And so it's just a piece of the puzzle. I don't know why these are going out of order. So I don't know if, I imagine that there definitely oyster farms are doing their own surveillance. I'm just not familiar with the details of that. I know Washington State does a lot of environmental testing. They will test a lot of shellfish, but they're not testing for overall. What they're looking at are sort of markers, indicators of increased Vibrio and increased toxic or increased pathogenic Vibrio, but it's not, because there's so many other variables, like was the shellfish harvested in the middle of the day? Was the tide, were the tides especially low that day? Was the temperature especially high that day? It's just a piece of the puzzle that you look at. Does that make sense? I hope. If the same lot of oysters consumed are still available at retail, it is not. So that is, it is not recommended to impound the lot. And the reason is, so these are really good questions. So is this a single source exposure? I'm going to skip that question. What is the medical treatment? Good question. So most people will get better without treatment. Most people will get better without treatment, but if they go to their doctor, often they will be prescribed antibiotics. But it's most people will get better without treatment. If you have severe illness such as septicemia, then or really bad skin infection, you will get treatment. You will get antibiotics, and that's appropriate. Sometimes restaurants have shellfish that are purchased from a market. Oh, so they do not have tags. Yes, would you recommend doing an investigation of the market where they purchase a shellfish to do the traceback study? Boy, this is a good question. So I think they should always have tags. So if they don't have tags, then I would go back to that market and figure out why they're not tagging the oysters. That's my answer to that one. Where in the COVID form asks for the shipping certificate numbers? Are there several? Do you know which ones they actually need? I just put on all the ones that I have. And you know what I do sometimes is I will actually copy that from the information I get from my shellfish program, and I'll paste it into a Word document and attach that to the COVID form. So I know the COVID form doesn't have a lot of rooms for those certificate numbers, and that's what I will do. Good question. They also don't have enough room for dealers. And a lot of other information. So I sometimes I will attach a page. Done. When there are several shippers listed, which ones are the most important to ID on the COVIS form? Try and list all of them. This is the same question. So I will put those on a separate page and I will attach that to the COVIS form. I think it's important to have all of those. Again, though, CDC does not necessarily, I mean, I think they put them into their system, which is great, but those really need to be sent to the regulatory agency that regulates the shellfish in that region where they were harvested. Does that answer that question? I think that does. Have referred operators back to their distributors when something they investigated does not have the tags. Yes, they should always have tags as far as I'm aware of. I mean, even they think they should always have tags. If they don't have tags, that's a problem, because the whole idea is to be able to do traceback. So if the distributors haven't provided tags, then that is definitely a problem. If the same, are the oyster farms doing surveillance? So I think I answered that. I believe they are doing, in some cases, probably the larger companies are doing their own surveillance. But then again, you can't necessarily tell by just testing for Vibrio parahemolyticus in the oysters whether it's pathogenic. You have to look for pathogen markers. If the same lot of oysters that was consumed by the patients are still available at retail, is it recommended? I do not believe so. So if somebody from environmental health can correct me on this, I've never had anybody impound a lot. Mostly because we don't know for sure if the illness is attributable to that, usually. So I've referred, any other questions live? Anybody want to ask a question? Oh, so Heather Watson says they have impounded a lot. Okay, well then I would check with your local I would check with your local food safety program and find out if they want you to do that. I don't believe, yes.
Oh, go ahead. There are a couple of comments in the chat box that addresses a couple of comments that were made. I could read them if that would be helpful.
Yes, go ahead.
Okay, so Lisa Yee, thank you so much. I have read that temperature influences the Vibrio's ability to float in warmer temperatures and sink into the sediment in cooler temperatures, but I don't have the citation off hand at the moment. Thank you so much for hosting this webinar. It's so informative. And Susan from California shared that California Retail Food Code requires untagged shellfish to be impounded.
Oh, so that's a good point. So untagged shellfish, that's a different question. I thought you were talking about shellfish that were associated with an illness. So untagged shellfish, that's one of the steps in the investigation was to identify, confirm the approved source. Untagged shellfish is by definition from an unapproved source. Is that correct? So if there are no tags, though I do know some restaurants will have their tags in quite a bit of disarray, and it'll be really hard to tell which shellfish go with were sold on different dates. That's one issue that has come up. So can you please revisit the different diagnosis options and why whole genome sequencing is not very accurate? So diagnosis, you can either do culture, or there's CIDT or PCR testing for stool. Culture gives you an isolate stool. The PCR testing just says it was detected, yes or no. Culture is confirmed and PCR is probable. It's a probable case. Whole genome sequencing, it's not that it's not very accurate, it's just not as specific for particular oyster, for particular shellfish. And the reason is because shellfish get moved around. One strain may predominate in one area. I can't remember what my other reason was, but it's not that it's not accurate, it's just it's not very specific. It's not as specific as it is for salmonella. If an end user restaurant purchases a product wholesale from a distributor, including a seafood market, the seafood market is required to provide a tag. So I believe that they should always have tags. Does somebody else have a comment on that? I would love to hear it. And the chat, so I have a question for Susan Seilers. What if the rest was oh, she's answering me right here. So if okay, so that's a really good question. So that's a really good point. So I would check with your, what your particular state, each state has their own retail food code, and check and see what that retail food code was. So I should have just referred to that in the first place. So whatever your state requires, but as far as I know, all shellfish should have a shellfish tag. Definitely warmer temperatures. I mean, obviously will help Vibrio proliferate. obviously it's not going to survive, cooking temperatures. So I'm not quite sure. Maybe I don't understand that question. Bad bud book. That's always a great resource to look for. Optimal perihumidicus is 20 degrees Celsius to 35 degrees Celsius, but can grow up to 41 degrees Celsius. Great. Thank you, V. And
there's a comment from Heather.
Yes.
In the question section.
In the questions. Great. Yes, they should have the tag, but okay, that's a good point. They should have the tag. You will not always find the tags. Or you may find the tags and you will be very challenged to figure out which one goes with the shellfish that were sold on the day you're asking about. I think people can probably commiserate with, or kind of agree with that.
I don't see any additional questions or anything.
Is there any live other questions? Thank you so much, everybody, for being here today. I hope I've answered your questions okay.
You know what I like? Oh, there's another from Emily. Oh, thank you so much, Emily.
Thank you, Emily. Okay, so this is from the FDA Model Food Code. Containers of shell stock that does not bear a tag or label, that bears a tag or label. So it is subject to a hold order. So this is the FDA Model Food Code, and probably each state has their own food code. But this is the food Bible, and I think I misunderstood the question. I thought it was whether shellfish associated with an illness should be held. So I apologize for that. And I guess that's anything else that anybody else? Oh, I see there's more questions.
You know,
do you see gastroenteritis from swallowing water or licking water off lips? I have not personally seen this, but every year we get a few cases of Vibrio. Actually, I'm sure this may happen because we do get cases of gastroenteritis where they deny having any seafood exposure. And some of these could potentially be from swallowing seawater or brackish water. I just don't think it's very common. I don't know if licking water off your lips is enough. Freezing does not kill the Vibrio. Definitely, yeah, I would not count on freezing to kill Vibrio. I mean, it may kill the Vibrio, but I wouldn't count on it. And also shellfish are hardly ever, let me think about that freezing question. I know it doesn't kill norovirus. Does it kill Vibrio? Let me think about this. It probably does, but I wouldn't count on it. I don't think that's considered I don't know if that's considered a kill step for shellfish. If they ate shellfish and were also in the water, do you perform an investigation for both sources? No, you only do an investigation for the shellfish if it's gastroenteritis. If it's a skin infection and they ate shellfish, you only do the investigation for the water. Any data on Vibrio associated with shellfish holding tanks at markets? There definitely could be post-harvest abuse. There could be temperature problems in shellfish at markets. We've actually seen Vibrio vulnificus infection associated with tilapia held in tanks at markets in Washington State. King County had a couple of cases a few years ago, and that was when people who purchased tilapia from live tanks and they injured themselves while they were cleaning them. So yes, that could happen. And those were skin infections. We find sometimes the supplier can fill in the gap with regards to the missing tags. So that's where you would get the invoices. And sometimes you could put 2 and 2 together by using the invoices, and you could put that together and find tag information. Vibrio can be pseudo-dormant states when temps are below 50 to 55. They can also, and then when they get up, they can start growing again. One issue with Vibrio is they can also go into a viable but non-culturable state when they get too cold. So keep that in mind. If they get really cold, they can go into viable but non-culturable. We've had that issue with isolates. All right.
Laurie, I don't see any additional questions or in the chat box. We are 8 minutes past, but these are such awesome questions. I'm wondering, I could grab the questions that were asked and the answers to them and then send them along with when we send out the slides, if that would be helpful. If that would be helpful, if you could type in the chat box, yes, that would be helpful. Okay, thank you, Lisa.
That would be helpful.
I would
Okay.
do that just for Lisa. And SK, massively
Multiple
helpful.
people think it would
There
be
you go.
helpful.
If you, okay, anybody who says massively helpful, done.
Okay.
All right, we'll do.
And are we going to send out the slides too?
It will be posted on our website.
Okay.
And the recording, including this live and Q&A, will also be included in the video and audio. But I'll also type it in as a text, because sometimes I also like it as a text as well.
Yeah, I think the Q&A chat is not going to maybe be viewable.
Exactly. So I will do that.
Okay. There's a print report of the questions from Zoom, but it doesn't include the answers. Okay, great.
I will make it easy for folks. Okay, super. Thank you so very, very much, especially to Laurie. I know this took a huge amount of time as you're in the middle of an outbreak or investigating an outbreak.
Thanks, everyone.
Thank you so much, everyone. Have a great day.